Hey, what is up guys? Ricardo here, and today we have a tutorial on one-dimensional kinematics. In this video we're going to cover a quick review of the formulas involved in kinematic physics, and we'll go through some practice problems using these formulas together. Alright, let's dive into it, team. So the first thing I'm going to do is going to quickly write out all the formulas. So the first one we got is V is equal to U plus A times T. Second one is V squared is equal to U squared plus 2AS. Third one is S is equal to U times T plus half AT squared. Last one is S is equal to V plus U over 2 times T. Now, if you haven't come across these before, I'm guessing this is going to be very confusing, so let me just quickly explain. So these four equations each interrelate certain qualities of final velocity, initial velocity, acceleration, and time to each other. And so, at least in this variation of them, I've used S to denote displacement. U is equal to the initial velocity. V is denoting the final velocity. And A is, of course, denoting the acceleration. And T is denoting the time taken. Now the units, of course, of this displacement is in meters, initial and final velocity are in meters per second, acceleration is in meters per second squared, and time is in seconds. So let's go through these equations one by one now, just to get a rough idea of what they're saying. So this first one is saying that the final velocity of an object is equal to its initial velocity plus its acceleration times time. The second equation is saying that the final velocity squared of an object is equal to the initial velocity squared plus 2 times the acceleration times the displacement. This third formula is saying that the displacement of an object from its starting point is equal to the initial velocity times time plus half times acceleration times time squared. This final equation is saying that the displacement of an object is equal to the final plus the initial velocity over 2, or in other words, the average velocity, times time, which makes sense, right? That would just be a rearrangement of the sort of velocity formula. Okay, so in certain textbooks you might see different letters denoting each of these. V and U are often used as V subscript F and V subscript I as final initial velocity. And S is often denoted by either a D or an X, depending on which textbook you consult. A and T are pretty constant. You might sometimes see delta T rather than just T, delta S instead of S. It would all sort of say the same thing. Important thing to remember is that these equations only work when the acceleration is constant. Okay, let's dive into some practice questions. So, if you want to pause it here and have a go at it, I'd recommend that, and then we can regroup in a few seconds and go through it together. Alright, so this is a sort of biological application of the kinematic formulas. It's a question you might see in like a GAMSAT test or a medical school entrance exam test. That's sort of why I put it in here, is because I know lots of you guys that come across here are sort of studying for these sort of exams, and it's sort of my background as well, so I can help you go through it. So let's go through it. Blood slows down as it travels further away from the heart. At one point closer to the heart, the blood is traveling at 0.9 meters a second. At another point further from the heart, it is traveling at 0.6 meters a second. It does this over a distance of 0.2 meters. What is the deceleration of the blood? Alright, well the first thing to do when approaching any of these problems is just write out what you have. So what do we have here? We have that as one point closer to the heart, the blood is traveling at 0.9. So that's the initial velocity. So we have U is equal to 0.9 meters a second. And then we have at another point further down, it's slowed down a bit, and its final velocity is 0.6 meters a second. So we have U and V. Next, we also have that it did this over a distance of 0.2 meters. So we have S, which equals 0.2 meters, and we're trying to find A. Now, can you figure out which equation that you'd have to use in order to solve this? Well, let's go back. So we have V, we have U, we have S, and we're trying to find A. And so that sort of looks like we can use this one here. We have V, U, S, and we're trying to find A. Alright, so let's just write it out again. V squared equals U squared plus 2AS. Alright, so in this case, we have 0.6 squared equals 0.9 squared plus 2 times the unknown A, which we're trying to find, times S of 0.2. Alright, working with the maths a bit here, this gives us 0.36 is equal to 0.81 plus 2 times 0.2 is 0.4, so 0.4a. Rearranging further, we'll subtract 0.81 and we'll get negative 0.45, which is equal to 0.4a. We'll divide both sides by 0.4, we'll get negative 0.45 over 0.4 equals a, and this equals negative 1.125 meters per second squared. So how'd you go? Did you get that right? If not, was it a problem of mathematical rearrangement or calculation, or was it a problem of sort of understanding and using the formulas? If it's a problem of mathematical rearrangement, that's a good sign. If all you did was sort of forget to carry the 1 or do something like that, it means but use the correct formula, it means you're sort of doing the right process. With these sort of questions, it's always very important you make sure that you've got the negative signs in the correct places and you're very sort of meticulous with your calculations. Alright, let's move on to the next one. If you want to pause it here and have a go at it, more than welcome to. Alright, so we have a man, and he rides his bike at a leisurely pace of 8 meters a second. He then sees the ice cream shop up ahead and accelerates at a rate of 4 meters per second until he reaches the truck 3 seconds later. He then slams on his brakes and gets an ice cream. What was his speed just as he reached the truck? Alright, like anything, let's write out what we have. He's riding his bike at a leisurely pace of 8 meters a second, so we can assume is his initial velocity. Sees the ice cream shop overhead and accelerates at a rate of 4 meters a second squared. So we have his acceleration is equal to 4. And he reaches the truck 3 seconds later. So we have t is equal to 3. What was his speed just as he reached the truck? So we want to find v. What is v? Can you figure out which equation that you need to use in order to solve this problem? Let's go back. So we want to find v. Alright, so that leaves these 3 equations. We have u, a, and t. Alright, so that one's out. That one's out. And that leaves this top equation. Did you get that right? Awesome. So let's rewrite that equation here. V is equal to u plus a t. So we're trying to find v, so it's already rearranged for us. That's very nice. U is 8 plus 4 times 3, which equals 8 plus 4 times 3, 4, 8, 12. 8 plus 12 is equal to 20 meters a second. So his final velocity was 20 meters a second. How'd you go? The maths in this one was a bit easier, so if you got it wrong, I'm guessing it might have been choosing the wrong formula. So you might want to review that if that's the case, but if not, let's keep powering through. Alright, we'll pause it here and have a go. More than welcome. Alright, let's go through it. So we have Scruffy the dog, and he's laying down enjoying a nice afternoon at the park. Suddenly, Scruffy's owner throws a ball and it lands 40 meters away. It's got a good toss. Scruffy jumps up and chases the ball, accelerating at a rate of 8 meters per second. How long did it take Scruffy to reach the ball? Alright, let's do the usual. Let's write down what we got. So Scruffy's owner threw the ball a distance of 40 meters. So S is equal to 40 meters. Scruffy jumps up and chases the ball, accelerating at a rate of 8 meters per second squared. And we're trying to find how long it took Scruffy to reach the ball. This seems a bit odd. We only have 2 known values. In order to solve any of these kinematic equations, we need 3 known values and 1 unknown. This is where things get a bit challenging, because if you read the question, you can see that Scruffy is not moving at the beginning. He's laying down enjoying a nice afternoon. And so with that information, you can deduce that his initial velocity is 0. Now, can you see which equation you'd need to use? Well, let's go back. So we have SATU. So we're trying to find let's see what we're trying to find. I've forgotten. We're trying to find the time. We have these values, and so we're trying to find the time. So that leaves these ones. We have his initial velocity, so that U, alright. We have acceleration, alright, yep. And we have distance. Okay, so that leaves this third equation here. Awesome. So let's rewrite that equation. I'd always encourage you to write the equation before subbing in the values. That way it sort of helps get it stuck in your mind, and before you know it, these equations will be second nature. Alright, so 40 is equal to, well, 0 is his initial velocity, so we can just cancel out that term. And then we're just left with half times a times t squared. Alright, so 40 equals half times 8, which is 4 times t squared. Divide both sides by 4. We're left 10 equals to t squared. Take the square root of both sides. We're left that t is equal to plus minus root 10, which equals plus minus 3.16. Now it can't be a minus time, because that doesn't make any sense. So therefore the answer is plus 3.16 seconds. How'd you go there? Hope it's sort of making sense now, guys, and you're getting the gist of it and getting into the rhythm. You know, read a problem, write down what you have, find the equation, and solve it. Right, last problem for the day. We want to pause it and give it a shot. Alright, let's go through it. Bonnie the bunny hops at a distance of 20 meters in 5 seconds. If her final velocity was 4 meters a second, what must have her initial velocity been? And what was her acceleration? Alright, so we got Bonnie, and she's jumped a distance of 20 meters. She's done this in 5 seconds. Okay, her final velocity is 4. What must her initial velocity have been, and what was her acceleration? Well, let's just try and find her initial velocity first. And so what equation will that be? We have STV, and we need U. Go back to the formulas again. We have STV, and we need U. STV, oh, it's this last one here. Alright, so let's go back to the problem. And we write down that S is equal to V plus U over 2, the average velocity, times T. we know that s is 20, v is 4, times t, which is 5. Divide both sides by 5, we get 4 is equal to 4 plus u over 2. Times both sides by 2, we get 8 is equal to 4 plus u. Subtract 4 from both sides, we get her initial velocity is equal to 4 meters per second. Alright, so that's interesting. Her final velocity and her initial velocity are the same. And so, with the second part of the question, what was her acceleration? Well, you could go ahead and go sub these values now into a separate kinematic equation. Or, if you sort of understand what is meant by acceleration, which is the change in velocity, the rate of change in velocity, you can see that if her velocity hasn't changed, if she has had a constant velocity, therefore she has had no acceleration. And so you can know just conceptually, and from understanding the concept of acceleration and how it relates to velocity, you can know that her acceleration was 0 meters per second squared. Go ahead, if you want to double check your sort of kinematic equation using skills, see if you can find the equation that's required to find A and see if you get 0 meters per second squared. But apart from that, guys, I hope this video was useful. I hope you learnt to sort of how to approach one-dimensional kinematic problems. Remember, first thing is read the problem, figure out what you have. Write it down. Once you know what you have, look at which equation best meets that need. Remember, you need to have 3 knowns and 1 unknown. If you've only got 2 knowns, there's probably a hidden known in the writing of the problem. It could be that the object was dropped, for example, and if it's dropped, it must have started at rest. A bit like in the Scruffy problem, Scruffy was at rest, and that was not explicitly stated, but it was implicitly implied in the writing of the question. So guys, thank you very much for sticking with me through this tutorial. I hope it was useful. If you have any suggestions on what you want in further videos, let me know. If you got any sort of ideas on how I can improve my videos, also let me know. I'd love to hear it. Until next time, guys, keep working hard and happy studying.